You're distracting me. Do you see this?
Okay, don't chop your hand off. Whatever you do, don't chop your hand off.
No. Oh, no. Oh, no, no, no. Oh. You're hindering my craft. That's the most disgusting thing I've seen today. I don't know. In last period, I saw somebody break both of their legs at the same time, and this is worse. This is worse. Well, not like in real life, but like, you know. Oh, what are we learning today?
Polar equation.
Okay, but like specifically.
Area under the curve.
Have you never cut like anything in your life? Okay.
Obviously.
Uneven surface. It doesn't matter.
All right, it doesn't matter. All right, so yeah, so last period I kind of have struggled through technology, but this period should be a lot better because I set up already. So I'm gonna start with the area under the curve first. So in here, the area under the curve is gonna be 1/2 integration between A to B. Austin, you gotta take a test today.
Yeah.
Yeah. F theta square d theta, or you can write as 1/2 integration A to B of r square d theta.
Is that a B?
Yeah, that's like a
R. It's a R?
this is r.
So then what's a B?
B is the from one angle to the next angle.
No. I'm chilling. Oh, God, it's cheap. You would be. Is there any like, is there like an easy way to understand why they had that formula, or just?
Okay, let's try it. If you have the area of a sector,
Yeah.
what will be the area this sector here? Like this sector here.
Oh, arc length times radius.
Actually, it can work if no arc length times no s equal to no you're not wrong in some way is something to do with you can multiply by the arc length and
yeah, like 1/2 arc length radius. Arc length times radius. I need he's close, like a triangle kind of.
what
He's close, right? So it'd be like
s equal to arc theta. So the arc length. Okay, so let's try this. So we know that area of a sector is what? Of this sector is the angle divided by I need a bit in radians, so that's why there's a 1/2 in the front.
Is it like pi squared times theta over 2 pi, and then the pi cancels, you have like 1/2
theta squared. 1/2 r squared. So area is equal to pi r squared, right? Now if you times by, you have a central angle. So what is the central angle? Theta over 180. Or theta over pi over 2. Oh no, this is 360. Sorry, 360. This is 360, so this is 2 pi, right? So therefore is, oh thank you. I think you just solved it. So pi is equal to r squared theta half.
with with no pi.
Pi is gone.
Yeah, there's still a red one.
Yeah.
Yeah.
So then you will have, so this is pi r squared, this is a central angle. Okay, so if a central angle, the pi is going to cancel out, so it's going to be 1/2 r squared theta. Now the theta is going to, so the central, you're going to break up the data into infinite amount of sections. So that's going to be the d data. So each slice that you're going to have, like each slice you're going to have here, so like each slice you're going to have here, is going to be the d data here. So therefore you got d data r squared, which is from here. The 1/2 is from here. Did that help you, Daniel?
Mm-hmm. Yeah. So you're deriving that, integrating that equation, right?
Yeah. So basically for AP exam, you just only know this equation.
Wait, are those two equations say the same thing?
Yeah, because R is another way to say f of data. It's like Y saying.
No, I'm talking about the one on the top and then the one next to the circle.
Next to the circle is where they derive from. So if you want to find the area of a sector of a circle, it's always pi r squared times the percentage of a circle, which is percentage of a circle is going to be angle over 360 or over 2 pi.
Okay.
And pi is going to cancel, so that's equal to 1/2 r squared theta. So this is 1/2 come from, r squared come from, theta has come from.
Right. So then, what is that equation on the top? What is that to find?
That's area inside a polar curve. So this is area within the polar curve.
Yeah, but how come that translates to that if we like
if you integrate it, how does that work?
So basically, you're just adding up small slice of things, because we're finding like one small piece of area of sector, and we just add them all up.
It's like, so theta is the difference between one line and the other line. That's d theta, right? It's the angle between each line. And so when you do integral, d theta approaches 0. Well, basically theta becomes d theta instead. And when you take the integral adds up all the
Slices, just like you integrate area under the curve. Except now the orientation is different from what x value to what x value. This one is from what angle to what angle.
I'm not sure like
Sector of a circle. So if we want to see if it works, right? If we want to see it work, we can just pick a radius as equal to 4. And that's a polar equation, right? Yeah. So we want to know like how much is a, let's just say 8, because we got 8-inch pizza. Like we have an 8-inch radius pizza. If we go to like Papa John's, whatever. So if I do 8, which is the r square, d theta, and if we want to say one slice of pizza, well, one slice of pizza is how many radians? 0 to what?
180 or 2 pi.
No, we are talking about one slice. Just if a pizza cut to 8.
Oh, 8.
360 divided by 8. Oh.
In radian.
Power 4.
Pi by 4. And we know this 1/2 outside. So we know like traditionally we do pi r squared times what? Times the
Theta over 2 pi.
Theta over 2 pi. Yeah, so theta is going to be pi over 4 over 2 pi. So it's what?
The pi cancel out.
It's supposed to be 1/8 of the circle, right? So that's the same thing as you talk about 1/8 circle. So if you have pi, this is 64 times 1/8. So this one's 8 pi, right? So let's try here. Integration this. If you have 8 squared, then it's going to be integration of 64 d theta between 0 to pi over 4, half. And that's going to be 64 theta between pi over 4 to 0, 1/2. And that's 64 times pi over 4 times 1/2. So it's equal to 8 pi. So this 8 pi in geometry is 8 pi. is find out exact same thing. Using calculus or using geometry, exactly the same thing. This is using basic geometry. This is using a calculus if I integrate it.
But usually there would be like an R would equal to the equation.
Yeah, R equal to polar equation, so that's what we're gonna do next.
So we're gonna have to do like actual integrals with this stuff.
Yeah. Unfortunately.
Okay, again, why can't we just use that formula that we used on the right instead of this whole integration?
Because now we're gonna actually using polar equation. Now the polar equation is gonna be something like this. R equal to 3 cosine of 3 theta. So now we are no longer using the R equal to 4 is R equal to 8 is still a polar equation. It's just a circle center at 0 with a radius of 8. So R equal to 3 cosine 3 theta, then that's gonna be a little bit different. So first of all, we talk about how many petals, right? So we says if it's R theta is gonna be the same amount of petal, same petal. I don't know how to spell petal. Is that how to spell petal? Petal. Oh, P-A-T-E-L? P-E-T-A-L?
Wait, petal? Like as a flower? Or
Yeah.
petal as a
Flower.
Oh,
T-A-L. So same amount, right? Same amount. Now if you have even theta, which is this is even, then you're gonna get
That's
double amount of petal. So we can show you how that work. So I'm gonna turn off this. I'm gonna say 3. 3 is gonna be distance away from the pole, and you're gonna have to type in R. I don't know why they don't have table. If they have table, it will be so much easier. So R equal to 3. That's the circle with the 3. If I have a cosine of theta, that's just gonna be a circle that is leaning to the right. But in this case, this is a 1 petal rose curve. This is actually the funny thing is if you do integration between 0 to 2 pi, you're actually gonna get double of the circle because they actually retrace the graph twice. We talked about that before. Now, if I change this to 2, they will give me 4 petals. So even amount of data is going to give you double amount of petals. If, huh?
Can you do 3 again?
Yep, I'm going to do 3. So if I do 3, it's going to give you 3 petal. If it's a 4, it's going to be what?
8.
It's going to be 8. Now, if it's a 5, then let's go back to 5. And 6, go to 12.
Can you explain like how that works?
Okay, so what I'm gonna try. Last period I tried, I failed. I'm gonna try to do a better job this period. So what I would think about is to at least show you how the algebraically works, right? So if I were to do, if I set an equation equal to 0. So why do I set equation equal to 0? Because that's how you retrace back to the 0. So I'm gonna show you here. I'm gonna show you the first graph. And if you pay attention, the way I change the thing is from negative pi over 6 to pi over 6. But if I plug in 0 for theta, I'm gonna get 3. So that means a single point right here all the way to the 3 on x-axis.
Wait, one more time. Sorry.
Okay, so I'm gonna plug in here to show you. So let's just say if I plug in here, that if I plug in data and there's R, if I were to plug in, let's say it's 0, that's going to be 3 cosine of 3, 0, and that's equal to 3 cosine of 0, which is 3. So that's how you get that point here on the right of this first point of that petals. Okay, so let's go with the pi over 6. But if you pi over 6, it's going to be 3 cosine of 3 times pi over 6. So that'd be 3 cosine of pi over 2. So 3 cosine of pi over 2 is what? 0. So it's going to be 0 here. So what happened in between? Well, I can just try something like, say, pi over 12. Okay. What happens 3 cosine of pi over 12? I'm going to maybe show you a better graph. So we have at 3. So we're gonna assume that this is a polar graph. So first point is at 3. What happened at pi over 12, which is half of pi over 6? So it'd be 3 cosine of 3 pi over 12. What will happen? So it'd be 3 cosine of pi over 4, right?
3 over 2.
So it's equal to 3 root 2 over 2. Can somebody figure out what's 3 root 2 over 2 using calculator? So we're going to assume that this is pi over 6. So it's going to be half of this. It's around half of this. 2.1. So it'll be about 2.1. So I would say probably somewhere around here. Is that okay? Somewhere around here?
Yeah.
And then so you're going to come back, and according to the 0, it's going to trace back. Is that okay?
Wait.
That's going to give you the half the paddle. Now, if you go the other side, it's going to give you like this, because this is at pi over 12. When you go into at pi over 6, then that's going to go back to the 0, because we plug in pi over 6, that's going to give me 0. Now, if I do this same thing here, then it's going to go to this point and this point. So the paddle is going to be coming back like this. So anyway, you can draw out this, and this becomes your paddle between this two graph. Oops, my bad. Between those two graph here, it's going to be pi over 6 and negative pi over 6. And that's going to give you a one paddle. So I'll show you on Desmo, because Desmo does fairly better job than I do. So this is between A, which is the first one, the red one, is going to be between negative pi over 6 to positive pi over 6. It's going to form that one perfect paddle there.
Do you just want to chart, or do you also want to plot the dots?
I don't need you to plot the dots, because the graphing calculator can plot the dots for you. I just need a graph. Oh, you wanted the actual dots on the decimals?
Do you know how to do that?
I don't know how to do that. Do you know?
Yeah.
Let's do that later. We'll figure out that. Tomorrow we can do other things. Or Monday. So is that okay? That's gonna give you one paddle. Now you're gonna say, well, what happened to the second paddle? Why do I only do one paddle? Because you remember the graph traced twice. If you do, some people say that, well, if my original question says, hey, can you find the area of r equal to 3 cosine of 3 theta, and it's gonna be from this, it's gonna be like this and like this. Sorry, that's not a very good job, but it's gonna be like this. And then you say, okay, I just want to find out this area right here. So what you're going to do is you're going to take this function between negative pi over 6 to pi over 6. Well, how do I know it's negative pi over 6 to pi over 6? Because you can set this cosine of 3 theta equal to 0. When's cosine equal to 0? Pi over 2. Can you figure out that's pi over 6? That's the first one. That's when they come back to 0. You figure out what's the next one to come back to 0. When's the next one to come back to 0? Well, cosine of 3 theta is equal to 3 theta is equal to negative pi over 2. Why do I do negative pi over 2? Because I can go backwards. So that's going to be theta is equal to negative pi over 6. So that's why I picked those two values. Now, can you pick a different value, get the same answer? Yes, absolutely. You can pick this part as 3 pi over 2. You should get the same exact answer, because that's just the next paddles. And next paddle is actually located, I think it's located at this spot, if I remember correctly. It's not like this spot. It's actually at this spot. Because you're gonna get negative r, it's on still first quadrant, it's gonna trace the graph on this side. So I'll show you what happened. The second paddle. Now this is the first paddle, this is the second paddle. From pi over 6 to pi over 2. Why? Because one paddle is from negative pi over 6 to pi over 6. That means one paddle is from radian from pi over 6, negative pi over 6, that's roughly pi over 3. So if you went from pi over 6 adding pi over 3, that's going to give you pi over 2. So you see that the second line is retrace that. That's the second paddle here. Is that okay? So what we're going to do is we can find out the area of the first paddle. The area of the first paddle is going to be this, 1/2. We know it's 1/2 r squared. Well, r is going to be 3 cosine of 3 theta. And then we're going to square this and d theta. And if I do this workout, you're going to say this is a lot of work. It's not as bad as you think because something is nice. This one's going to be 3 squared, so it's 9 cosine of 3 theta squared d theta. And what makes it easier is I can take out the 9 outside, the 2. Now, luckily, on AP exam, they don't need you really calculate this by hand. If they do, it's probably something relatively easy, not like this particular one. Okay, Jerry, you following?
Yes.
Okay, cosine 3 theta d theta. Now, when you get to here, well, how do you suppose to integrate something square? This is going to be on your math competition tomorrow. How do you integrate sine square or cosine square? Power reducing. So how do I apply this to power reducing? Power reducing is says what? Sine of 2 theta is equal to what? And the cosine of 2 theta, so we care about this one. Cosine square. Okay, cosine cosine 2 theta is equal to what? Oh, sorry, cosine square theta is equal to what?
Sine theta cosine theta.
No,
2 sine theta cosine theta.
no.
Oh, wait, sine of 2 theta or sine squared?
Cosine square theta.
Okay.
1 plus cosine 2 theta.
1 plus cosine 2 theta? You're missing something else. Divided by 2.
Yeah.
Good. Now you realize this is theta, right? But this is 3 theta. So can I change this to 1 plus cosine of how many theta? 6 theta. Good job. Is that okay?
So what was the point of the sine 2 theta?
No, I'm just, don't worry about this. I read wrong. This is power reducing. So now I'm just write down just in case that doesn't make sense. If I have cosine of 3 theta here, then that's going to be 1 plus cosine of 6 theta because you double this. Can I take out 1/2 out? So it'll be 9 over 4, integration of negative pi over 6 to pi over 6. So it'll be 1 plus cosine of 6 theta. Is this okay? What's integration of 1? What's integration cosine 6 theta?
6 theta. 6 over 6. Yeah.
Yep.
Got it.
So 9 over 4, and between pi over 6 to negative pi over 6. Now, interesting thing is you can plug in pi over 6 here. What is sine of 6 pi over 6? Which is sine of pi. And sine of pi is what? 0. So it'd be 9 over 4 of pi over 6, right? Plus 0. And then minus, what is the next one? It's going to be minus negative pi over 6 plus sine of negative pi over 6 is also sine of negative pi. Sine of negative pi is 0, so 0. So it's actually the answer is much easier than you think. So because it's pi over 6 plus pi over 6, it's going to be pi over 12. No, sorry, pi over 3. So pi over 3 is going to give you 3 pi over 4. That's the final answer. Now, this is only one paddle, right? This is only this paddle. If I ever want to find 2 paddles, then I just multiply by 2. If I want to find 3 paddle, it's going to give me that. But the problem is some people says, hey, I could have just done this, 0 to 2 pi. That means that's all 3 paddle. But the problem of, there's a small problem when you're doing this. So this is what most people make mistake. Mistake happen is they say they want to take a shortcut. They take the 0 to 2 pi of this and just divide it by 1/3. So this is 1/2 and 3 cosine of 3 theta squared d theta. And they say I can just multiply this by 1/3. That's going to give you 1 paddle. But unfortunately, that's actually give you 2 paddle and then 1 and 1.
Two paddle. Wait, what?
That actually give you 2 paddles because the way about this is they actually trace it twice. So if you look at cosine 3 theta like this, and if it's 0 to pi, see 0 to pi is already traced once already. So you see that green one? 0 to pi is already traced once. 0 to 2 pi is just traced twice. Same graph traced twice. So you actually find the area of 6 paddle rather than 3 paddles. So you cannot take this area and say, oh, I'll just divide it by 3. No, you at the time, if you do 0 to 2 pi, you had to do divided by 6.
So would it work with 3 pi? You do it like 3 pi, you just divide it by 3. That would work, right?
You can do, like, say, cosine of 4 theta, then just divide it by the whole area by 8, which just makes sense. That means 1 paddle of the 8 paddles. So anyway, I won't take a shortcut. The problem is people taking a shortcut, they do this, and this is bad because it's not exactly 1/3. It should be 1/6 because it's 3 paddle traced twice. If you want to be smart and quick, yeah, that would be actually pretty smart. Just do, if this is odd, then just double it, divided by 6, right? If it's even, just divide it by 4, right? If it's odd, if it's 8, then divide it by 8. Wait. Yeah, depends on what the data is. So you can actually reverse engineer that. You can actually think very quick and solve the problem in 10 seconds. Just do 0 to 2 pi. But if you want to be safe, it's going to be, you find out whether equal to 0, find out what the 1 paddle is, and then just integrate that 1 paddle. And sometimes they even ask you just 1 paddle. They just ask you 1 paddle, and that's going to be fine.
Do you ever get like negative answers?
Oh, yeah.
That's true. Would they get negative answers?
Like for certain functions, would you ever get like a negative area?
If you start going back.
You're going backward just like before. You're going backwards. You should get negative areas, right? So let's just say, yeah, so integrate between pi to negative pi, right? And to, let's say, 4 d theta. I don't know if this work. Yeah, they give you negative.
Would it be possible to get negative? If you just trace it for any.
Yeah, that's what I'm curious about.
So like you know how if you take like integral of like, so if you're doing in terms of like continuity, right? It's the graph. Even though you're going forward, so you can't do that with forward.
Can you though? If
I don't know.
If there's like a backwards line. I'm just curious if that would like mess up.
What does the backward line look like?
Well, like the negative graph. Negative.
Even if you add negative.
I was just curious if it would mess up any answers if you try to think about the whole function. Like if it would subtract some of the pedals instead of adding them, if they were like made of entirely negative radii. Yeah.
You can try it. I don't know. I gotta say, this polar part is not one of my. Yeah, that's not, but it's a good question. I would say that's a great question. Any questions about this part?
Can you go over the part where it was like data, like how many paddles? What do you mean by same amount of paddles?
Okay, so if it's odd, it's 3 theta, right? It's gonna be 3 paddle. It's a 4, it's gonna be double.
4, so 8 paddles?
Yeah.
Okay.
But basically, this still 6 paddle, but you just don't see it. It's just basically trace the same paddle twice.
Oh.
This is why we need a 3D polar plane.
You should invent one.
So it makes more sense if you see it in 3D.
Yeah, I don't think it's just gonna be straight, so it's not gonna
You need to like get one that also tilts a little bit based off the data, but then put it by like half so that you have it like.
Have you seen that unit circle? Have you seen unit circle? Have you know something called Fourier transform? I think I showed you before, right? So Fourier transform can actually use any sign graph to graph anything with a function. So let's say if you want to graph Simpson, there's a video of they use Fourier transform to graph Simpson using the equation. Have you seen those before? Let me see if I can show you. How to spell Fourier transform? Fourier. Transform Simpsons. Homer Simpson.
You should just from there.
No, Mr. E said he wants to take it home.
No, I just, yeah. I didn't want to.
You know, Kevin brought me a watermelon once. I invited him over one night. He just came with a watermelon.
Have you seen this before?
Watermelon and fried chicken.
No, that's Irby. Irby has the chicken.
This is all building with a bunch of equations.
He has the chicken back here.
Oh yeah, I've seen this one.
Ow.
That's a graph. That's one like continuous graph.
Yeah.
All rotating like pendulum. Rotating at like constant rate, each one. There's just a lot of pendulums that rotate.
That's one graph.
Oh, pretty cool.
Yeah, so this is Fourier transform basically have
Oh shoot.
actually this guy did even better.
Wait, what was that slider do?
It increases the number of pendulums.
Oh, okay.
So it's like
So it makes it like smoother?
yeah.
Weird.
So they're all rotating at the same rate, or not the same rate, but
Yeah, they're all rotating at
like
constant rate.
yeah.
And they're connected to each other.
Interesting.
So this is not polar. This is actually Fourier transform. It basically uses sine and cosine functions
Ah, cool.
and construct this in terms of this.
I want to see like the formula.
I don't know. They do draw a lot of different things though. That's this is the first guy who did it. It's like 15 years ago. Can you stop doing that shit? I'm about to throw it on your face.
Like Michael Jordan with watermelon.
Okay, so does that make sense? So this is the actual explanation about how Fourier transform works. He did a pretty good job by explaining. So yeah, this is a draw another one. So it's pretty cool. This is another one that I don't know if you guys saw the sine wave. They don't have anymore. I don't know what they had. This one. This is basically a sine wave that you were talking about, like change the
Yeah.
yeah.
If you did it but had it go up,
Yeah.
by you would have like 6.
That's what it did. But this is actually pretty cool because
This is what they did. Is that software like available?
this software, I don't know. I think him did a lot of different things by the
Like I
same
wonder if
time.
you could do that with 3D desktops. Like
Probably you
I kinda
can.
wanna try this.
Okay, if you cut your finger off,
I'm not gonna. I'm safe.
okay, you know what? Don't touch your knife. You know,
I've been
there's like a
doing-
lawsuit waiting to happen.
Look, I've done.
And
great
I'm
work
gonna
with the
be
knife so
one
far.
of the part of the lawsuit, and I don't want to be in. And next thing I know, I'm gonna get fired
Don't
because
worry,
I let
yeah.
a very childish person to use knife.
Yeah, no, that's valid. Don't worry, I have formal knife training. I'm a Boy Scout.
You know how to whittle.
I do.
So this is the sign graph. Do you see this?
Yeah. Oh, did you cut it off?
Yeah, I got you.
Me too.
Oh shoot. Wait, that's so.
So this is actually 3D. And not only that, you can see a unit circle in a second.
Ooh. It didn't work too well yet. Yeah.
Good sign.
But I need it to be like, I need it to look like the same thing.
What are you doing?
He's graphing like the 3D.
Nah, I broke it.
You broke it.
Pretty much.
Is that all we were learning today? The
Autograph. And we're gonna do a harder one tomorrow. Monday. No, we're gonna do two other things that's a bit harder.
today?
No, not today. Like, I think this one is already hard to consume.
I made a thing.
Not bad.
It like, I don't even know what it is. It looks kind of funky.
That's pretty cool. What is it? What is the equation?
It's r equals 3 cosine 3 z theta. So it's r equals 3 cosine 3 theta, but I put the height on the inside of the cosine.
You know, watermelon has like all zero
Mm.
values.
In Z's.
Watermelon.
Oh, I need to figure out how to combine equations.
Rain, help man. Probably.
I'm sure there's like vitamins. Yeah, but there's like not that much.
Really?
Mm-hmm.
Really good. Sweet.
Because it's not like a strong flavor.
Who made the cake?
What do you think?
Oh, he made some.
So long as the two sine waves have the same. There's some
I want to try.
Okay, no, I'm serious. No, don't do it. Can you go get a paper towel and wipe it off? Because people are gonna step on it and it's gonna.
It's dry. Am I pissing you off that much today, Mr. Ye?
Yes.
Really? I was focusing in class and shit.
Yeah, but can you just walk over there and throw away?
Yeah, my fault. I was looking in.
Yeah, should I just take a test now?
You can. Did it work out?
No, because I don't know how to like combine equations. Because I need this one and the height equation to be like.
Told you that.
You come in tomorrow, right?
Yeah. What time and where?
Someone has
Did you get it?
What time?
Who was the
8:20,
one
yeah,
time
be there.
in-
Okay.
Don't be late.
8:20.
I'm good.
Don't be late.
That's the most racist.
I mean, honest, you guys.
I got life session again today. I was late first period. What's that?
Stupid.
I know.
There's more
right?
penalty for being late than.
Yeah, there were, half my class was absent. Half of my class was absent.
Oh, I think that's Austin.
And,
And jack shit happens to them.
Congratulate Austin for that.
Crazy.
You're right.
why is today's skip day or
That's fine.
something?
Yeah, I think so.
Dude, that's so fun. Yeah, yeah.
Hmm. You finally the pickle here. Senior also?
No, she's in 8th grade. Okay. No, she's a senior. What's our homework looking like today?
It's right here.
feel bad for that boy though. Like he was so mad. He was like, it wasn't 4 months actually. It was 6 months. I was so.
They were, or then he was crying.
Yeah.
And then you come along. You're.
And she was talking about him on the day too. She was like, "Oh yeah, I think he actually liked me for a bit, but it was just weird." Damn, it's the.
Which way do I
I texted him. I was like, "It's the evil world we live in."
It doesn't matter.
No,
Just
no,
take
I
what-
gotta show you the exchange I had with this guy.
Oh yeah, we got.
Because he started coming for me, so I was just not holding back. But
You have a stapler?
Over there.
where is it?